Separation of duties. Opening. The administrator who could end everything. Consider a senior systems administrator at a regional bank. 12 years of service, trusted completely, holds the keys to virtually every system in the environment. Their access was accumulated gradually, the way most excessive access accumulates. Each grant made for a specific, reasonable purpose at a specific moment in time. They administer the production database servers. They manage the backup infrastructure. They hold the credentials to the tape library. They can modify retention policies. Nobody planned for one person to hold all of those capabilities simultaneously. It simply happened because each individual grant made sense at the time it was made, and nobody was mapping the aggregate. Then comes a period of personal crisis, a divorce, a financial collapse, a disciplinary proceeding at work. And one afternoon, working quietly and with methodical intent, this administrator deletes the production database. Then, knowing that the first question the recovery team will ask is where the backups are, deletes the backups. Then modifies the retention logs to make it appear the backups have been failing silently for weeks. By the time the incident is discovered, the path to recovery is close to non-existent. A single trusted person, using only the permissions they legitimately held, has effectively ended the company's operational capability. The investigation that follows asks the right question one step too late. Why did one person have the ability to do all of that? The answer, of course, is that nobody designed it that way deliberately. No security policy said, grant the backup administrator permission to delete production databases. What happened is what always happens in the absence of separation of duties. Access accumulated, roles blurred, and over time a single individual acquired the complete capability to execute a critical process from beginning to end, with no independent check at any step. Separation of duties is the structural response to this failure. Not a technical control in isolation, not a policy in isolation, but a design principle. No single person should hold enough capability to complete a sensitive or critical process entirely on their own. The principle distributes power across people in the same way that defense in depth distributes controls across layers. Not because any one person is presumed to be malicious, but because the potential for harm from any single compromised or failing point should be bounded. Power that requires more than one person to exercise is power that cannot be abused or accidentally misused by any one person acting alone. This session is about developing a precise understanding of where that principle applies, what it demands architecturally and procedurally, how it is verified by the people whose job is to verify such things, and what the failure modes look like when the design is correct, but the governance is not, or when neither is. The foundation, what the principle protects against and how. The principle of separation of duties is not a single idea. It encompasses several distinct but related concepts, and the distinctions matter because different failure modes require different design responses. The most direct form is the two-person rule. A sensitive action cannot be completed by a single person acting alone. It requires the participation, knowledge, or approval of a second independent party. This is the model used in Nuclear Command Authority. No single officer can authorize a launch, and in financial wire transfer systems, no single employee can both initiate and approve a transfer. The nuclear and financial examples are not coincidences. They represent domains where the consequence of a single corrupted or compromised actor is so catastrophic and irreversible that a structural check is worth every operational cost it imposes. A subtler but equally important form is the principle of non-repudiation, which separation of duties both enforces and depends on. Non-repudiation means that a party cannot credibly deny having performed an action. In electronic transactions, digital signatures achieve non-repudiation by cryptographically binding an action to the key of the actor. The signature proves that the holder of the private key authorized that specific document or transaction and cannot plausibly claim otherwise. In access control terms, non-repudiation means that the audit trail makes it impossible for an actor to deny having performed an administrative action. The log shows that account X performed action Y at time Z, and because access to account X requires authentication that is tied to a specific person, the action cannot be attributed to anyone else. Separation of duties and non-repudiation reinforce each other. When an initiator of a transaction is different from the approver, and both actions are logged with cryptographic attribution, neither party can deny their role, and neither party can act alone. The combination is what makes the control durable under adversarial conditions, including the adversarial condition of an insider who is attempting to cover their tracks. Due care and due diligence describe the organizational posture that separation of duties represents in legal and governance terms. Due care is the obligation to take reasonable precautions to protect against foreseeable harm. It is the standard of reasonable behavior that courts and regulators apply when assessing whether an organization acted responsibly. Giving one person unrestricted administrative access over both production data and its backups fails the due care standard in any environment where the value of that data is significant, because a reasonable organization in that position would recognize and mitigate the risk. Due diligence is the ongoing process of verifying that the precautions that were put in place are actually working, auditing access controls, reviewing the separation of duties architecture periodically, and confirming through testing and evidence that the controls operate as designed rather than merely as documented. The distinction between the two is important. Due care says you must put appropriate controls in place. Due diligence says you must verify they are working. An organization that designed a separation of duties control correctly but never audited whether it was being bypassed in practice has exercised due care but not due diligence. The governance layer where separation of duties is formally defined sits at the intersection of security policy and internal controls. A security policy states that sensitive processes require multi-party authorization. The internal control translates that statement into specific, measurable requirements. Which processes qualify as sensitive, how many parties must be involved, what the approval mechanism looks like, and how the participation of each party is recorded. Controls at this level are what external auditors and regulators examine when they verify that an organization's separation of duties architecture meets the standards their framework requires. A security control assessment, the formal process for verifying that controls are implemented and operating effectively, goes beyond confirming that the policy exists. It tests whether the technical implementation matches the policy intent, whether the people who operate the control understand it correctly, and whether the control would withstand a genuine attempt to bypass it. The structural tension, independence against efficiency. The central tension that separation of duties creates in every organization is between the independence that makes the control effective and the efficiency that operational environments require. Every step that requires a second party is a step that cannot proceed until that second party is available. At small scale and low frequency, the cost is minor. At high scale and high frequency, the cost can become a genuine operational constraint that creates pressure to find workarounds. And workarounds to separation of duties are, by definition, the failure mode the control is designed to prevent. Consider the developer access scenario. A production incident is discovered at midnight on a Saturday. The developer who is on call needs to examine a production server to diagnose the issue. The separation of duties posture says they should not have standing access to production servers. Their role is writing and testing code, not operating the production environment. The operations team holds production access. Getting an operations team member involved at midnight on a Saturday takes time that the incident does not have. The pressure this creates is entirely predictable. Developers are quietly granted temporary production access during an incident. The access is not revoked afterward, and within 6 months the developer has standing production access that circumvents the original control. The separation of duties architecture remains in the documentation. It has ceased to function in practice. The design response to this tension is not to eliminate the separation, but to design the exception mechanism with the same rigor as the primary control. The developer does not need standing production access. They need an escalation path that can provide scoped, time-limited, audited access to the specific system relevant to the incident, fast enough that the incident can be addressed without the process itself becoming the problem. A PAM solution with a self-approval mechanism for pre-approved scenarios. A developer on the incident response roster can approve their own temporary read-only access to production logs during an active incident, but write access still requires a second approver, provides the operational speed the incident requires without collapsing the control entirely. The access is time-limited and automatically revoked. The session is recorded. The approval event and the session are both logged. The separation is maintained for write access, where the real risk resides, while the diagnostic access that the developer genuinely needs can be obtained without waiting for a second party who is asleep. This design distinction between the operations that genuinely require two-party authorization, because the consequences of a single actor proceeding incorrectly are catastrophic and irreversible, and the operations that can be facilitated with tighter scoping and better auditing, is what separates a separation of duties architecture that works in practice from one that looks correct in a diagram and is routinely bypassed in reality. Architecture. Building the two-key design. Implementing separation of duties architecturally requires mapping the critical processes in an environment and determining, for each one, where the natural separation points are and what the control at each point looks like in practice. The contract review process for third-party vendors is an instructive example because it involves multiple organizational functions with naturally different interests and expertise. The business unit that wants to onboard a vendor has a strong incentive to complete the onboarding quickly. They have a project dependency, a product need, or a cost saving that drives the engagement. The security team needs to verify that the vendor meets the organization's security requirements. The legal team needs to confirm that the contract includes the appropriate clauses, including the right to audit the vendor's security posture, the notification requirement in the event of a security incident involving the organization's data, and the limitation of liability provisions that protect the organization if the vendor's failure causes harm. The procurement team manages the commercial terms and the approval authority. Separation of duties in this process means that no single function can complete the vendor onboarding unilaterally. The business unit cannot approve a vendor solely on the basis that they want to use it. The security team cannot block a vendor indefinitely without escalation. The legal team reviews the contract terms and the security clauses specifically, and their sign-off is required before the contract is executed. The procurement team confirms the commercial terms and issues the purchase order. Each party contributes a distinct domain of expertise, and the completion of the process requires evidence that each party has performed their specific role and that their sign-off is recorded. A vendor who enters an environment without having passed the security review or whose contract does not include the required security clauses is a gap in the separation of duties architecture of the vendor management process. Not just a missing step, but evidence that the control failed to operate as designed. Break glass accounts present the most challenging architectural design problem in separation of duties because they are explicitly designed for situations where normal access controls cannot be followed. The requirement is that break glass accounts exist, are accessible in genuine emergencies, and are not used for routine access. But the conditions that make them necessary are precisely the conditions in which oversight is most difficult to apply in real time. The architecture resolves this by separating the authorization to use the account from the account itself. The account credentials are stored in a physically secured location, a sealed envelope in a safe, or an offline vault accessible only with physical presence. The act of breaking that seal or accessing that vault generates an immediate alert that notifies the security team and relevant leadership. The session established with the break glass account is fully recorded. The account's password is rotated after every use so that the credentials from the previous use cannot be reused. The post-incident review that examines what actions were taken during the break glass session is mandatory, not optional, because the review is the accountability mechanism that makes the existence of the account compatible with a separation of duties posture. It is not the prevention of access that makes break glass accounts compatible with the principle. It is the certainty of post hoc accountability that does. The SDLC pipeline is where separation of duties applies most visibly to the security engineering community. Implementing secure development lifecycle practices in a CI/CD pipeline means building the separation between code authorship and code review, between test results and deployment authorization, and between the development environment and the production environment into the pipeline's mechanics rather than relying on human discipline to maintain it voluntarily. Static analysis runs automatically on every pull request and produces a report that the reviewer must acknowledge before the merge can proceed. The developer who wrote the code cannot approve their own pull request, and the static analysis results cannot be overridden by the submitter. Software composition analysis runs against every build and produces a dependency vulnerability report that must be cleared or formally accepted before the build can be promoted to production. Container image scanning runs as a gate in the promotion pipeline between staging and production. A build that fails the scan cannot be promoted, period, and bypassing the gate requires an explicit change to the pipeline configuration that itself requires review and approval. The SCSD tool and the developer are not peers in this architecture. They are playing different roles in a process that requires evidence from both before the next step can proceed. Tools that enforce the separation. For tools enforce separation of duties at different points in the workflows where the principle matters most, and each one does so through a distinct mechanism. Git pull request approvals are the most widely deployed separation of duties control in software engineering, and their effectiveness is more fragile than it appears. The mechanism is straightforward. A developer cannot merge their own code into a protected branch. Another reviewer must approve the pull request before the merge can proceed. The security value is that no individual developer can introduce malicious or vulnerable code into a production codebase unilaterally. At least one other person must have seen it and approved it. The cost is the review latency that approval requirements introduce and the organizational pressure that creates for reviewers to approve quickly without reading carefully. The limitation that makes this control weaker than it looks is the rubber stamp review. When a team has a culture of approving pull requests quickly to maintain velocity, the approval becomes a procedural requirement rather than a substantive check. The control passes audit because the approvals exist. It fails operationally because the approvals are not meaningful. Detecting this failure requires examining the timing and comments in approval history. A team where every pull request is approved in under 2 minutes with no comments is a team where the control is operating formally but not substantively. PAM dual authorization applies the same principle to the highest risk administrative actions. A PAM solution that requires 2 administrators to approve access to the root or domain administrator account before it is vaulted out enforces a genuine 2-person rule. The requester cannot be the approver, and the approver must be a specific authorized individual rather than any available colleague. The cost is the operational dependency on having a second authorized administrator available at the moment the access is needed. If the organization has only 2 senior administrators and 1 is on vacation, the control may create a bottleneck at the exact moment it is most likely to be needed, a major incident outside business hours when the available administrators are already stretched. The architecture must account for this by defining at minimum 3 authorized approvers per protected account category, distributed across time zones if the organization operates globally, and by ensuring that the emergency escalation path is tested regularly so that it works when it is needed. The limitation of PAM dual authorization is that it controls access to the vaulted credential but does not control what the authorized person does with it once they have it. Session recording and post-session review are the complementary controls that cover what the vaulted access policy itself cannot. CM audit logs enforce separation through accountability rather than prevention. The CM does not prevent an administrator from performing an unauthorized action. It records that the action was performed with full attribution in a log that is stored separately from the system the administrator controls and that they cannot modify. This separation of the audit function from the administrative function is itself a form of separation of duties. The administrator who manages the production systems does not manage the audit logs of those systems. A different team, the security team, the compliance team, or a designated audit function, reviews those logs and investigates anomalies. The effectiveness of this control depends entirely on the review actually happening. A CM that captures comprehensive logs, but whose logs are never reviewed, is a storage cost, not a control. The review cadence, the escalation path for anomalous events, and the independence of the reviewing function from the administrators being monitored are all requirements that the control depends on to function as designed. ERP financial workflow controls represent the industrial strength expression of the principle in the domain where it has the longest history and the most regulatory attention. An ERP system configured correctly for the financial services context encodes separation of duties directly into the workflow. The user who creates a vendor record cannot be the user who creates a payment to that vendor. The user who approves an invoice cannot be the user who processes the payment. These constraints are not advisory. They are enforced by the system's permission model and cannot be bypassed by any user acting within their normal access. The cost of this architecture is the operational burden of ensuring that the appropriate number of authorized users exists for each role in the workflow. If the company has only one accounts payable clerk, the separation of the initiation and approval functions requires either a second person in that function or a cross-functional approver from another department. The limitation is that ERP controls can be misconfigured. A permission model that grants a single role both the ability to create vendors and the ability to approve payments for those vendors has technically implemented the workflow, but has undermined the separation it was supposed to enforce. The compliance audit is the mechanism that detects this by testing whether any user in the system holds both roles simultaneously. Implementation, designing checks that actually hold. Two implementation scenarios require full treatment because they represent the engineering dimensions of separation of duties that are most directly relevant to the profiles in scope for this session. The first is the production debugging problem. A software development team requests full administrative access to production servers for the purpose of debugging an intermittent performance issue. The technical need is genuine. Examining production logs, querying production database metrics, and reviewing live configuration often requires a level of access that developers do not normally hold. The security concern is equally genuine. Granting the development team standing administrative access to production collapses the boundary between development and operations that the separation of duties architecture is designed to maintain. The resolution begins by decomposing what the debugging task actually requires. Diagnosing a performance issue rarely requires write access to production systems. It typically requires read access to specific log directories, read access to database query statistics and execution plans, and possibly the ability to run pre-approved diagnostic commands that do not modify system state. These are not the same as full administrative access, and the implementation should provide exactly what is needed rather than the nearest convenient broad permission. The practical architecture for this is a dedicated debugging role in the PAM system, scoped to read-only access on specific production systems relevant to the current incident, time-limited to the duration of the debugging engagement, and requiring approval from the operations lead who is jointly responsible for the production environment. The developer requests the debugging role, names the systems relevant to their investigation and the approximate duration they need, and the operations lead approves with a stated time limit. The PM system grants the scoped access, records the full session, and revokes the access when the time limit expires or the developer ends the session. The developer's role in development and the operations team's role in managing production are maintained. The specific investigative need is met. The approval of the operations lead creates an accountability link between the debugging session and the operational responsibility that the operations team holds for the production environment. The non-obvious governance requirement is the post-debugging review. When the session ends, the operations lead receives a summary of the actions taken during the session. Which log files were accessed, which queries were run, which command were executed, and confirms that they are consistent with the stated debugging purpose. This review is the check that closes the loop. It converts the time-limited access grant into a fully accountable transaction and it creates the record that confirms the separation of duties control operated correctly even during the exception. The second implementation scenario is the parallel run strategy for deploying a new pipeline version. A security automation engineer wants to replace a running pipeline that produces SOC handover reports and alert triage outputs. The new version has different parsing logic, different enrichment steps, and different output formatting. Deploying it directly to production means that any defect in a new version immediately affects the SOC team's operational output. The parallel run strategy is the engineering expression of separation of duties applied to the pipeline deployment process itself. The separation here is between the team that builds the new version and the team that validates it before it replaces the production version. In a small organization where the same engineer both builds and validates, that separation must be enforced through time and process rather than through different people. The new version runs in parallel with the production version, producing outputs that are independently reviewed for a defined period before any cutover decision is made. The mechanics of the parallel run require that both versions receive identical inputs. If the pipeline processes a live feed of events, both versions must be processing the same event stream simultaneously, either by consuming from a shared queue or by duplicating the feed. The outputs of both versions are compared automatically. A diff of the output files or a comparison of key metrics like alert counts and severity distributions run as a scheduled check that flags discrepancies for review. A discrepancy that the new version produces but the old version does not is either a genuine improvement. The new version is catching something the old version missed, or a regression. The new version is producing noise or missing something the old version handled correctly. Human review of discrepancies is required before the cutover decision can be made, and that human review should be performed by someone who is not involved in writing the new version, the operations team or the SOC team who consumes the pipeline's output, not the engineer who built the pipeline. The cutover itself is a deployment action that requires an approval step in the CI/CD pipeline configuration. The new version can be promoted to production only with an explicit approval from the designated validator, recorded in the pipeline's audit log. The rollback mechanism, the ability to revert to the old version within minutes if the new version produces problems in production, must be tested before the cutover is executed, not assumed to work because the old version still exists somewhere. A parallel run strategy that does not test its rollback path is a strategy that has the appearance of caution without the substance of it. When the separation failed, 3 diagnostic journeys. 3 failure scenarios each represent a different layer at which separation of duties can break down: governance, operations, and enforcement. And the diagnostic work for each requires addressing the layer where the failure actually occurred rather than the layer where the symptom appeared. The first scenario is the governance interpretation problem. Different departments are applying the NIST cybersecurity framework inconsistently, with some interpreting the protect function's access control requirements as requiring separation of duties for privileged administrative actions and others treating it as optional guidance. The inconsistency has produced both duplicated controls in some areas. 2 separate teams, each running their own access review process for overlapping populations, and gaps in others. An entire business unit whose backup and restore functions are handled by a single administrator with no compensating oversight. The diagnostic is a mapping exercise before it is a remediation exercise. Pull the documented control implementations from each department and map each one to the specific NIST CSF subcategory it is intended to address. The goal is to identify 3 categories: controls that correctly implement the subcategory, controls that implement the subcategory but in a way that does not actually achieve its intent, and subcategories with no implemented control. Separation of duties failures typically fall into the second category. The documentation shows a 2-party approval process, but the 2 parties are from the same team and report to the same manager, which undermines the independence that makes the control effective. The root cause in most inconsistency cases is that the NIST CSF was distributed as a framework without being translated into organizational standards that specify exactly what each subcategory requires in this specific environment, with this specific set of roles and systems. The framework says access should be managed according to least privilege and separation of duties. The standard needs to say which specific processes require 2-party authorization, which roles are considered independent for this purpose, how the approval is recorded, and how compliance is verified. Without that translation, every department head makes their own reasonable interpretation, and the aggregate result is inconsistency that looks like non-compliance on the outside, but is actually a governance gap that could have been prevented by producing the standard first. The remediation is not to mandate a single technology solution. It is to produce the internal standard and then verify that each department's implementation meets it through a structured self-assessment followed by independent validation. Departments that are over-controlled, running 2 separate access review processes where one would suffice, can consolidate without reducing protection. Departments with gaps can be given a specific, measurable remediation timeline tied to a risk acceptance for the interim period. The second scenario is the legal hold failure. A legal hold is placed on a former employee's documents and mailbox following the commencement of litigation. The hold is communicated to the relevant IT administrators with instructions to preserve all relevant data and suspend the normal retention policy. 3 weeks later, a review reveals that several documents that were subject to the hold were deleted by an IT administrator who received the hold notification but claimed they did not understand it applied to the data they were managing. The diagnostic opens at the separation of oversight failure. The legal hold represents a situation where one party, legal counsel or the compliance team, issues an instruction and a different party, IT operations, is responsible for implementing it. The separation of duties in the normal retention management process was not designed to handle this override, which is why the override failed. The IT administrator's retention automation continued running, and the hold notification was insufficient to override the automation without a technical intervention. Pull the hold notification that was sent. What did it say? Did it name specific systems, specific mailboxes, specific file paths? Did it instruct the administrator to take a specific action in the retention management system? Or did it only describe the legal requirement in general terms? The most common failure mode in this scenario is a notification that accurately describes the legal obligation but does not translate that obligation into the specific technical steps the IT administrator needs to take to implement it. The legal team knows what preservation requires. The IT administrator knows how to configure the retention system. In the absence of a standard process that bridges those 2 domains, the translation fails. The remediation has 2 layers. The immediate layer is a technical lock placed on the relevant data by the IT administrator with the appropriate system access, implemented immediately and documented with evidence that the lock is in place and cannot be overridden by normal retention automation. The structural layer is a legal hold procedure that describes exactly what must happen at the technical level when a hold is issued, which administrator receives it, what system configuration changes are required within what time frame, what evidence of implementation must be submitted to legal within what time frame, and what escalation path applies if the administrator cannot implement the hold without guidance. The procedure creates the accountability chain that the ad hoc notification approach did not. The separation between the legal function that issues holds and the IT function that implements them is appropriate. These are genuinely different expertise domains. The failure was that the handoff between them was not defined with enough specificity to be executed reliably. The third scenario is the SOC compliance audit finding. A security control assessment reveals that the two-party approval process implemented for privileged access to the organization's core financial systems is not functioning as designed. The assessment found that in 30% of elevated access sessions over the past quarter, the approval was granted by an account belonging to the same individual who requested the access. The requester and approver were the same person operating under two different account names. The diagnostic begins at the technical implementation of the approval workflow. Pull the PAM configuration for the financial systems access tier. What does the approval policy require? Does it specify that the approver must be a different user principal, or does it simply require that an approval event exist? If the approval policy checks for the presence of an approval without verifying the independence of the approver from the requester, the control has a design defect that anyone who holds two accounts can exploit. The fact that 30% of sessions showed this pattern strongly suggests that the individuals involved were not attempting to conceal the behavior. They may not have known it was prohibited, which means the organizational communication of the controls requirements was as defective as the technical implementation. The technical fix is straightforward. The approval policy is updated to check that the account issuing the approval does not share a user principal name, an employee identifier, or a manager relationship with the account making the request. Any approval issued by an account meeting those criteria is automatically rejected and escalated to a designated approver. The organizational fix requires a communication to all holders of privileged access that clarifies the independence requirement and explains why self-approval defeats the control entirely, along with an update to the onboarding training for privileged access roles. The compliance response is to assess the actions taken during the 30% of sessions that were approved through a self-approval pattern, review them against the stated purposes in the access requests, and confirm or investigate whether any of those sessions involved actions inconsistent with those purposes. 3 roles, 3 duties to separate. 3 roles encounter separation of duties at architecturally different moments, and what each one needs to do well in those moments reflects a different dimension of the principle. The security architect encounters the principle at the design stage of a new workflow, and specifically in the moment when they're defining which steps require independent authorization and which do not. The temptation in this moment is to apply the two-party rule to every step, because maximal separation feels like maximal security. The experienced architect resists this because maximal separation applied uniformly produces a process that is so slow and so dependent on multiple parties' simultaneous availability that it will be routinely bypassed in practice. And a bypass of the control is more dangerous than a well-designed control with a carefully scoped application. The architect's design methodology for separation of duties starts with a risk assessment of each step in the process. What is the worst possible outcome if a single person completing this step acts maliciously or makes a serious error? If the worst case is catastrophic and irreversible, deleting production data and its backups, approving a fraudulent payment to a controlled vendor, deploying backdoor code to a security product, the two-party rule applies. If the worst case is significant but recoverable, misconfiguring a non-critical system, approving a software deployment that introduces a bug, the appropriate control is a time-limited review window or a post-hoc audit rather than a real-time second approval. The architect documents the reasoning for each decision, because that documentation is what allows an auditor to verify that the design was deliberate rather than accidental, and what allows a future redesign team to understand the intent when the organization's risk profile changes. The security automation engineer encounters separation of duties in the pipeline architecture, and specifically in the design decision of what can be automated without human approval and what cannot. The SDLC automation is the domain where this distinction is most consequential. Automation that runs SASD against every commit and fails the build if critical vulnerabilities are detected is automation that enforces separation without requiring human involvement. The rule is the second party, not a person. Automation that can bypass the test results if a flag is set in the build configuration has introduced a mechanism by which the developer can override the check unilaterally, which collapses the separation. The engineer's design skill is understanding which controls are suitable for full automation, where the rule can be trusted to apply consistently without human judgment, and which require a human in the loop because the decision involves context that the automation cannot evaluate. The parallel run strategy is the automation engineer's most direct expression of separation of duties in their own work. Deploying a new version of a security pipeline to production is itself a privileged action with significant consequences if the new version has defects. The parallel run separates the development of the new version from the validation of it, and the validation from the authorization to deploy it, through a sequence of checkpoints that require evidence rather than assuming correctness. The engineer who builds the new pipeline version is not the person who decides it is ready for production. The operations team or the SOC team who receives its outputs makes that decision based on a structured comparison between the old and new version's outputs over a defined observation period. The compliance professional operates at the verification layer, and their specific moment is the control assessment. The formal process of determining whether separation of duties controls are implemented correctly and operating effectively. The distinction between those two things is the core of the compliance skill. A control that is implemented correctly means the technical mechanism is in place and configured as designed. A control that is operating effectively means that the mechanism is actually achieving the security outcome it was designed for in real-world conditions, not just in the configuration that the documentation describes. The assessment methodology for a separation of duties control starts with examining the design. What process was the control designed to protect? What is the separation point? Who are the two parties? And how is independence between them defined? Then it tests the implementation. Pull a sample of instances where the control should have operated and verify that the required approvals exist, that the approvers were genuinely independent of the requesters, and that the approvals were not granted under exceptional circumstances that became the norm. Then it probes the edges. What happens when the normal approver is unavailable? What is the exception process? Does the exception process maintain the independence requirement, or does it allow a single person to self-approve in an emergency? The answers to the edge cases are where most control weaknesses live, because exception processes tend to be designed for speed and convenience rather than for the same rigor as the primary control. Case scenario: the bank that separated its keys. You're the head of security at a mid-sized regional bank with roughly 400 employees and $300 million in assets under management. The bank operates a core banking system, a payment processing platform, a customer data management environment, and a network of branch systems. An internal audit commission following an industry-wide advisory about insider threats has produced a finding that the bank's current access model allows a senior systems administrator to independently access, modify, and delete data in the core banking system, its primary database backup infrastructure, and its off-site tape archive. The finding notes that this situation has existed for 4 years and that the current administrator has consistently received the highest performance ratings in the department. The finding is not an accusation. The administrator is not suspected of anything. The finding is a structural observation that the organization's current configuration allows a single individual to cause a level of harm that would be catastrophic and potentially unrecoverable, and that an organization of this size and regulated status is expected to have controls that prevent this. The regulator, when informed, would characterize this not as a vulnerability that happened to be discovered, but as a control failure that should have been identified through internal governance. The constraint shaping the remediation is that the bank operates 24 hours a day, 7 days a week, and that any change to the access model for production systems requires a change management process that includes testing, approval from the Technology Risk Committee, and a communications plan for operational staff. The change cannot be made unilaterally by the security team. It also cannot be deferred indefinitely. The audit finding carries a regulatory clock, and the bank's external auditors will expect evidence of remediation at the next annual review. The work begins with a map of the specific capabilities that need to be separated, because separating everything is both unnecessary and operationally disruptive. The core risk identified in the finding is the conjunction of 3 specific capabilities: right access to the production database, authority to modify backup policies, and authority to delete from the tape archive. The separation does not require removing any of these capabilities from the role structure. It requires ensuring that no single individual holds all 3 simultaneously. The remediation architecture separates the capabilities across 3 roles. The systems operations role retains right access to the production database and the ability to initiate backup jobs. It loses the ability to modify backup retention policies and the ability to access the tape archive management console directly. The backup administration role retains the ability to configure backup policies and monitor backup job outcomes. It loses right access to the production database. The archive access role governs access to the tape archive, and it requires dual authorization, a request from either the systems operations or backup administration role, approved by the information security officer before any archive retrieval or deletion can occur. The combination of any 2 of these roles by a single individual is explicitly prohibited in the access matrix and enforced through the directory service configuration. The emergency scenario: a production crisis at 3 in the morning that requires all 3 capabilities simultaneously, is addressed through a break glass procedure that is distinct from the normal role structure. The break glass account for the combined capability set is stored in a physical vault in the server room, access to which requires a physical key held by the on-call senior manager and a PIN known only to the security team. Opening the vault sends an immediate notification to the CEO's mobile number, the CTO's mobile number, and the CISO's mobile number. The break glass account session is automatically recorded. The session log is delivered to all 3 recipients within 2 hours of session termination, and the account password is rotated by the PAM system when the session ends. The procedure is tested quarterly in a tabletop exercise where the on-call team works through a simulated 3 a.m. scenario to confirm that the break glass procedure can be executed quickly enough to be useful in a real emergency. The change management process takes 8 weeks from the audit finding to the implementation. The Technology Risk Committee reviews and approves the new role structure. The directory service changes are tested in a staging environment that mirrors the production role model. The operational staff will be affected are briefed on the changes and given a 2-week transition period during which the old and new access models run in parallel under monitoring. The transition period catches one operational dependency that was not identified in the initial design. The backup monitoring script run by the Systems Operations role included a query to the Archive Management Console to verify that daily backup jobs have been archived correctly. The script was running with credentials that the Systems Operations role no longer holds. The script is updated to use the dedicated backup administration service account for the archive query, removing the dependency without the operational function. The parallel period is what made this catch possible. The parallel run revealed a dependency that the design review had missed. 6 months after implementation, the bank's external auditors review the new access model. They confirm that the separation of the 3 critical capabilities is implemented technically, enforced by the directory service, and evidenced by the access matrix review that the security team runs quarterly. They note one residual finding. The quarterly access matrix review has been completed twice, but neither review resulted in any remediation actions, which they characterize as a green flag that could potentially indicate a review that is being performed without genuinely examining the data. They recommend that the review process include explicit documentation of what was examined, what was found to be in order, and what criteria would trigger a remediation action. The recommendation is implemented. The review template is updated to require the reviewer to document the specific accounts examined, the specific separation checks performed, and the reasoning behind the conclusion that no remediation was required. A review that produces no findings without showing the work is not sufficient evidence of due diligence. A review that shows its work and reaches a clean conclusion is. Closing. The architecture of mutual accountability. There is a temptation in discussions of separation of duties to frame it as a control against bad actors, against the malicious insider, the fraudulent employee, the disgruntled administrator. That framing is accurate but incomplete, and it produces an organizational attitude toward the control that is subtly wrong in a way that matters. The control is at least as important as protection against the well-intentioned person who makes a catastrophic mistake. The administrator who accidentally deletes the production database while attempting to clear a test table is not a bad actor. The developer who pushes code they believe is correct, but that contains a critical vulnerability is not a bad actor. The finance employee who approves a payment they believe is legitimate, but that is part of a business email compromise is not a bad actor. Separation of duties does not assume malice. It assumes fallibility, and it designs the system so that fallibility in any single person cannot produce irreversible harm without another person either catching the error or sharing the accountability. The deepest value of the principle is not the harm it prevents in the cases where bad actors are successfully stopped. It is the organizational culture it produces when it is embedded in the processes that govern how critical work gets done. An organization where consequential actions require multiple independent parties to participate is an organization where those actions are taken more carefully, documented more rigorously, and reviewed more honestly than in an organization where any one person can do anything alone. The accountability that separation of duties creates is not just technical. It is social and organizational, a shared understanding that the people who handle critical processes are accountable to each other, not just to a policy. Designed for that accountability from the beginning. Build the check into the workflow rather than the culture alone. Verify that the design is operating as intended rather than as documented. And remember that the moment the control is treated as a formality, when the second approver clicks approve without reading, when the break glass is used because the normal process feels slow, when the review template is completed without genuine examination, is the moment the architecture reverts to one person making all the decisions. The form of separation without the substance is just overhead. End of session. Separation of duties.